And so if it is acidic, then to get pH, we have got to use all of the work we've done so far to use the hydronium concentration, not the acid, but the hydronium. And so for all of our examples, then we should have the hydronium concentration available to use after we finished the Rice chart and all the calculations. And if it was equilibrium, we've solved for X. So we should have that. And so the first example practice problem was the hydrogen cyanide, the hydrocyanic acid. So I think it was 0.75 molar. Yes. So our 0.75 molar HCN, that is not the hydronium, that is the original dissolved stuff. Only a small amount of those hydrogens transferred. And so from our chart, we figured out by doing all the calculations that our hydronium was 1.9 times 10 to the negative 5. So what I recommend that you do is that you write down that concentration of your original weak acid. So it was a weak acid. And then from the Rice chart in our calculation, we got that hydronium was 1.9 times 10 to the negative 5 molar. That way you remind yourself that they're not the same thing. You did all that work. This is what we wanted. And now we can use this to get the pH. So we were just going to plug it in. pH equals negative log of 1.9 times 10 to the negative 5 molar. So my calculator, I have to type the number in first, then I have to hit the log, then I have to hit the negative 5. So I got 4.72 for a pH. That is acidic, because it's less than 7. The closer to 0 it is, the more hydronium, the more acidic it is. So this is not close to 0, it's closer to 7, because that is a really low concentration because it was a really weak acid. Were there any others that were acidic that we did? Yes. Okay, we had 0.75 molar HNO4. Is that right? ClO4, HClO4. Is that one of them? This one was strong. So from our Rice chart, we figured out that the hydronium was also 0.075 molar. So why was it the same? It's strong. So when you're doing this, again, I recommend that you remind yourself why the numbers won't match when it's weak, but they will match when it's strong. Just as a like reinforcing where these numbers have come from. Okay. So this is our value that we take the pH of. So it's pH of the negative log of that hydronium. This concentration is much higher than the previous one. So our pH is going to be much more acidic. So it's going to be closer to 0. So I got 0.12. That is acidic. So if you look at these two, both of them are 0.75 molar acid. This one is more acidic because more hydrogen came off our acid molecule and became hydronium, because pH is a measure of the hydronium, not the acid. So any other acids in the practice problems, you'll do the same thing. Just go and look at each example and just pull the concentration of your acid, and then underneath it, write down the rice chart hydronium concentration, and then use that to do the pH. And since they're all acids, the pH should be lower than 7. The weaker the acid, the closer to 7 it's going to be. Okay. So the opposite of an acid is a base. So we also had quite a few bases. So the base, there is one additional step that we have to do to get to pH. So you want to separate them from the acid and label everything very clearly. And so for the bases, you're going to have hydroxide. You're going to get that information from the rice chart. So hydroxide is one of your products, and you should have done a chart, which we have done a lot of them, where you get hydroxide. But that is not hydronium, that's hydroxide. There is a constant equilibrium between hydroxide and hydronium in water. So we have to do a little equilibrium water calculation. So this is just what happens in water. So you're going to take your hydroxide concentration and put it right there. And when you rearrange, every time it's going to look like hydronium equals your constant for water divided by the hydroxide from your rice chart. Then you're going to plug that number into the pH equation. And since it's a base, you should have a pH more than 7. There is another version of, there's another kind of example, like instead of doing this, you can do something different. If you want me to give you the other option, just see me later. I'm just choosing to approach it this way. Okay. There's 2 approaches. Well, there's more than 2, but so is there more than one way to do the same thing? Yes. I'm just doing it this way to keep things kind of consistent for what we're going over. Okay, so let's go back to some of the examples that were bases. So what was one of our first bases? The very first rice chart that we did was 0.75 lithium hydroxide. That was the very first one that gave us hydroxide. From the rice chart, our hydroxide was 0.75 molar. It is the only kind of strong base that we're going to go over, and that's if when the substance dissolves, there's hydroxide right there when the ion. So this is not exchanging a hydrogen, this is just ionizing. So all the rest of them are weak. You're going to look in your chart and get your OH concentration, and then you're going to plug it into hydronium. You can go ahead and rearrange this because it's the same every time. Your hydronium is going to be the constant for water divided by your concentration of hydroxide. So it's a 1 right there. 1 times 10 to the negative 14 divided by 0.75 is going to be our concentration of hydronium. So 1 EE negative 14 divided by 0.75 equals 1.3 times 10 to the negative 14. That is so small. Okay. With this, we're then going to take the negative log of this value, and it should be between 0 and 14. When you do the negative log, your pH is going to end up being somewhere close to what the exponent number is, because it's taking the number and turning it into 1 times 10 to the something. And so the number, your pH is going to be near 14 up here. That is 7.5 times 10 to the negative 1. So that's 0.1. Okay. 1.3 exponent negative 14 log 13.9. 13.9 is near the exponent. It's negative log. Okay. So for each of your solutions, go back, find the hydroxide and hydronium, and do this process. And then you should be able to do most of the homework all the way to the last 2 questions on the homework. So there's a KAKB, conjugate acid base example, and then there is a bunch of solutions. And all the solutions are either acidic or basic, and I have them in a logical order. It goes strong, strong, weak, weak, ionize it, and so it gets like similar, and then equilibrium with KAKB stuff. So
Yes.
see if you can do some of those examples.
Sorry.
On Thursday, we're going